Related rates. So we've talked about implicit differentiation, where what you're deriving, the variable you are deriving in relation to, is different than the variable that you have. So like we have been deriving with respect to x, and when we get to a y variable, then we have to put dy dx. And dy dx just really means how is y changing with respect to x, okay? And so we are going to move towards related rates. And what related rates do is they have multiple variables, like this volume problem for a cone. Volume is pi over 3 r squared times h, which is just your pi r squared times h, your cylinder volume divided by 3, right? That's your cone volume. So in this case, when you look at something like this, you'll see they're draining this cone. So they have this cone-shaped guy here full of water, and they're draining it out. Well, the water represents the volume, right? And then you have multiple things changing. The radius is changing, right? The radius starts here and it's going down. When you get here, you can see the radius down here is way smaller than the radius up here, right? The height of the water is also changing. The height of the water starts here, but as you drain the water out, the height changes. What are they all changing with respect to? They're changing with respect to time. Over time, the water is draining out volume. Over time, the radius is changing. Over time, the height is changing. None of those variables are the time variable. So anytime you derive something like this with respect to yet another variable like time, then you are saying, how is the volume changing with respect to time after 2 seconds, after 3 seconds? How is the radius changing with respect to time? How is the height changing with respect to time? Just like we said, how is y changing with respect to x, okay? And so when you start taking these derivatives, you then go back and they've given you pieces of it. They'll say after 3 seconds, that's your time. Or they'll say the radius is 3 after, is changing at a rate of 3. Well, changing at a rate of 3 is your change in radius with respect to time. So they'll go back and tell you pieces of it that you can plug back in and solve. All right. So basically what we're doing is we're going to take some known formulas, and we're going to start with just x's and y's, but we're going to take some known formulas and we are going to derive them with respect to yet another variable. So each piece of it has to have a dr dt, dh dt. However, each piece is changing with respect to that next variable. All right. So let's look at it just with x and y. We're going to do implicit differentiation with x and y, and then we're going to look and see that they give us a piece of it. All right. So let's look at the, for example here. Suppose x and y are both differentiable functions of t, all right? And they're related by this equation, y equals x squared plus 3. Find dy dt when x is 1, given that dx dt is 2 when x is 1, all right? So they have given us several different pieces. The first thing we need to do is find the derivatives, because if we don't have the dy dt or the dx dt, we don't know where to plug these things in. Notice that they have told us x and y are differentiable functions of t. So we are finding all of these with respect to t. If there had been a t variable in my equation, I would derive it just like I did my x's without a dy dx. But this is all with respect to t. So every time I derive a variable other than t, I need to do that variable with respect to t, just like I would do dy dx, all right? So let's take the derivative. What's the derivative of y? Well, it's going to be 1. Now I am saying it is with respect to t, so I am saying dy dt. What's the derivative of x squared? Well, that's 2x, but I am saying with respect to t, so now I have to say dx dt, and just like anything else, my 3 will zero out. My 3 will zero out there. All right. So what have they told me? Well, they've said find dy dt. They want me to find this guy. All right. When? Well, when x is 1. So they have given me x. And they have also given me that dx dt is 2 when x is 1. So they've actually already given me this as well. dy dt, I do not know. I know what my x is. X is 1. I know what my dx dt is. dx dt is 2. So my dy dt is going to be 4. What did that tell me? That told me that when x is 1, y is changing at a rate of 4. That's how it's changing, all right? That is the rate of change for y with respect to t there. A pebble is dropped into a calm pond, causing ripples to form of concentric circles inside of each other, right? The radius r of the outer ripple is increasing at a constant rate of 1 foot per second. When the radius is 4 feet, at what rate is the total area of the disturbed water changing? All right, so let's look at some keywords here, all right? First of all, they have told me that I am dealing with circles. That's important, all right? Because in your mind, your brain should go to circle formulas. Circumference, 2 pi r. Area, pi r squared. Like you know some things about circles, right? Way back from your past life there. The radius is increasing at a constant rate of 1 foot per second. So they've told me something about the radius. The radius is changing. Specifically, it is getting bigger. When the radius is 4 feet, so they've told me what the radius is, at what point they want me to look at this. At what rate is the area changing? All right. So not only have they told me circle, they've told me what about the circle I'm looking for, area. All right. So I know area of a circle, and I'm going to start there. I'm going to say, well, the area of a circle is pi r squared. All right. Pi r squared. So I am going to take this derivative with respect to time. All right. What is the derivative of just a? A is a variable. It's just 1 with respect to time. So then dA dt, right? 1 dA dt. Pi is a constant, right? So this is not the product rule. It's like if I had a 3 in front of the r, right? So how do I take the derivative of this piece? Well, I multiply by the exponent, 2 pi r to the first power. And this is with respect to time, which is a different variable. So I need to say dr dt. All right? And then I'm going to fill in the pieces that they gave me. This is my derivative. I'm going to fill in what they told me. Well, they told me that my radius is increasing. This is when they give a change, increasing, decrease, getting larger, getting smaller. That is going to be a derivative. How is r changing with respect to t? How is r changing with respect to t? It's changing at a positive 1 feet per second. So my dr dt is just 1. That's what they told me. That's how it's changing, 1 foot per second. If they had said it's decreasing for some reason, like if you were taking something out and it were decreasing, you would put a -1 there, right? Negative mean decrease, positive mean increase, right? They've also told me something else. The radius is 4 feet. Well, how do I know to put that where the r is and not the dr dt? Well, because that is not a changing thing. The radius is 4 feet. They didn't say it was changing at a rate of 4 feet per second. They said it is 4 feet. When it is 4 feet, that's going to go where just a variable is. All right? So they've also told me this guy right here is 4. So they want, what are they looking for? They are saying, at what rate is the area changing? Well, which of these represents the change in area? Which of these represents change in area? Right, that's going to be my final answer, but the variable is this guy, right? So if I solve for this, I have solved for the change in area. So 2 times 4 times pi, that is 8 pi, all right? So it is changing at a rate of 8 pi feet per second. And if they wanted a decimal there, they would say round to the nearest whatever, okay? when you solve related rate problems, you're going to identify all quantities that you have and quantities that you don't have to be determined. Make a sketch if you need to, label it if you need to, write an equation involving the variables, use chain rule, implicit, whatever you have to do with respect to the other variable. And typically on this other variable, it's going to be time, with respect to time. After you've taken the derivative, go back and plug in the pieces that they've given you. All right? They want to start getting you thinking about the words that they have and versus what does that translate to algebraically, right? So the velocity of a car after traveling for 1 hour is 50 miles per hour. If x represents my distance traveled, they told me my dx dt, 50 miles per 1 hour, right? Water is being pumped into a swimming pool at a rate of 10 cubic meters per hour. When they're talking about filling something up, they are talking about volume of water. So the volume is changing at a positive 10 cubic meters per hour, all right? And by the way, if they say cubic, they're also talking about volume. That's their 3 dimensions, right? A gear is revolving at a rate of 25 revolutions per minute. Angle of revolution is what they're talking about. It is revolving 25 revolutions per minute. Remember, 1 revolution is 1 circle, so 1 circle is 2 pi. So it's revolving at 50 pi radians per minute. So you have to start thinking about, if they are telling me something is changing, then they are telling me d something dt, all right, the changing. Let's look at this next example. Air is being pumped into a spherical balloon. All right, spherical balloon, that's important, all right? So it is at a rate of 4.5 cubic feet per minute. Find the rate of change of the radius when the radius is 2 feet. So I have a spherical balloon. If I am putting air in it, I'm talking about the volume of a spherical balloon. The volume of a sphere is 4/3 pi r cubed. All right? So the very first thing is I have to decide, what formula am I talking about? I'm pumping something in, filling it up. That's going to be a volume. They told me sphere, spherical, 4/3 pi r cubed. All right? So then I have my formula. The first step I need to do is find my formula. So find your formula for whatever word problem you are doing, all right? The next thing you are going to do once you have your formula is you are going to take the derivative with respect to time. So every single variable is going to be with respect to time. The derivative of v, that's just 1 dv dt. Here, these are both constants. 3 times 4/3 is just 4 pi r squared, but again, dr dt. All right? Now, what did they give me? So we're going to plug in what they give me. It says the rate here that they gave me is 4.5 cubic feet per minute. 4.5 cubic feet per minute. All right? If they gave me cubic feet per minute as a rate of change, which of these did they give me? Which one isn't going to be in cubic feet? What are they telling me? The air is being pumped into a spherical balloon. Did they tell me how the radius is changing, or did they tell me how the volume is changing? The volume. If they are pumping air into the balloon, the volume of the balloon is what they told me. 4.5 cubic feet per minute. That is the volume of the balloon. So that's where we're going to put the 4.5 cubic feet per minute is going to go right here. 4 and pi, those are both. All right. It says the radius is 2 feet. What did they give me? The r or the dr dt? The radius is 2 feet. Which one did they give me? The r or the dr dt? Is it changing? Did they say it's changing? No. If it is stagnant, not changing, they gave me a variable, not a changing variable. So if they gave me radius is 2 feet, that is where I'm going to put it, where the radius is. And they said, find the rate of change of the radius. Which variable do they want me to find? dr dt, right? So dr dt is the one that I do not know. And now I have a basic algebra problem, right? And I think they actually, because it's in radians here, they actually converted this guy to 9/2. Not 8. So this is 16 pi dr dt. Divide both sides by 16 pi. You are going, and I actually think, I don't know why they changed it, because they actually converted it. So you actually get 9/32 pi, but they actually converted this to decimals anyway. So you could have left it. In the book, they changed it. If they have the answer in decimal, like if they say round to the nearest 100th, leave it as a decimal, you're fine. But they said it's approximately 0.09 feet per minute. Remember, you're talking about the radius changing, so this is one dimension. You notice it's not cubed, it's not squared, right? It's just feet per minute. And I got that from, by the way, if you go back up here, how do I know what my units are? Well, they told me the radius is feet. They told me cubic feet per minute. So I know my time value is in minutes, and I know my measurements are in feet based on that word problem. And you do need to pay attention to that, because the last thing you want is for them to give you one in feet and one in yards or inches or something, and you don't convert one before you start doing this process. An airplane is flying on a flight path that will take it directly over a radar tracking station. And they give you the picture here. If S, that's just the hypotenuse, the actual distance to the station. If the actual distance to the station, which would be this hypotenuse, right? So you can see that this is the distance that is changing, right? Is decreasing at a rate of 400 miles per hour when S is 10. Then it wants to know, what is the speed of the plane? Now, a couple things they show you in the picture that they didn't actually tell you in the words. They're telling you that the plane is 6 miles high in the air, right? So if you did not have a picture, they would say that somewhere in there. When the plane is 6 miles above the ground, right? What's going on? Well, a couple things is they've also told you the Pythagorean theorem piece of it here. They've told you the 10, the hypotenuse. Okay, so I want you to understand that when they have given you two sides of a right triangle, they have given you the third side because of the Pythagorean theorem. So they gave us 6. They also said that we know for a fact we're going to figure this out when S is 10. So we can actually also figure out what X is when S is 10, right? And so we do that with the Pythagorean theorem. We can say, well, we have a squared, which we don't know, plus b squared, which we do know, equals c squared. So we can actually figure out that x is 8, right? 100 minus 36 is, right, 64, and then square root of 64 is 8. So we actually know when s is 10, when the height is 6, and when the horizontal distance is 8, right? So we know that it is 8, 6, and 10 here, because that's how it has to be. It's a perfect Pythagorean triple. All right, so what we do want to think about is the fact of what they've actually given us. We know that x squared plus my height of the plane, which is technically not changing, right? The plane is not getting lower, so that's actually not a changing variable. Does that make sense? The reason I filled out the x as a variable is because the horizontal distance is changing. The vertical distance is not. So the vertical distance is constant. That plane is not landing, all right? So I left it at a 6 because that 6 is not a variable, okay? I just used the 6 to figure out what my horizontal would be when the hypotenuse was 10, right? But my x is technically a changing variable because where it is right now is not what that 8, because it's moving. The plane is moving horizontally. So x is a changing variable. That's why I put an x there, all right? 6 is not a changing variable. So I put the 6 there because it is a constant. The plane is not going up or down. The hypotenuse is also a changing variable because the distance to the station is changing as the plane flies horizontally, all right? So this is the formula. I'm still going to use my Pythagorean theorem because those variables are based on each other, okay? A squared plus b squared equals c squared. But I filled in a constant for the guy that is constant, and I left the other two as variables. Does that make sense? All right, so I'm going to take my derivative of this. 2x. Well, with respect to time, I also need to do a dx dt. I don't even have to worry about that 6 squared. Why? Because when I take the derivative, it doesn't matter if it's 6 squared or 100 squared. What's going to happen to it? It's going to zero out, right? Because I'm taking my derivative. So this guy zeroes out. The hypotenuse is changing to s with respect to time. All right? So they want me to say, what is the speed of the plane? All right? So we have to think about what that represents. So I am going to say, well, the speed of the plane is going to be how x is changing, right? That's the speed of the plane. The horizontal distance or horizontal change is going to be the speed of the plane. Technically, it's going to be a velocity at this point, but we'll see it. So I am really looking for how is x changing? How is my horizontal distance changing? At what rate is it changing? Let's see what they gave me. S is decreasing at a rate of 400. They gave me a changing variable. So they didn't give me S, they gave me ds dt with that number, right? Does everybody see that? So I'm going to fill in decreasing. What am I going to fill in for the change of S right here? A negative 400, because they told me is decreasing. All right. 2, they also told me when S is 10. They told me that guy too. Dx dt, I do not know the change in horizontal because that's what I'm looking for. 2, I actually know what x is going to be. If my height is constant at 6 and my hypotenuse is going to be 10 when I answer this question, my horizontal distance is going to be 8. So I also know that one as well. And so I'm going to plug all this in, and I'm just going to, algebraically solve here. Dx dt equals 2 times 10 times negative 400. I'm just doing this so I don't actually have to calculate this, right? I can just cancel it out. So my 2's will cancel out. My 8's will actually cancel out with my negative 400, right? That's going to be negative 50. So I'm going to get negative 50 times positive 10 is negative 500. If it has a positive negative for speed, that's actually velocity. Okay, velocity incorporates direction, speed does not. Okay, does that make sense? Just like if you found a distance and you got negative, you would absolute value it, because speed is never going to be negative. Velocity will be. The reason this is negative is because the distance that it's getting is actually getting closer to the station, so it's actually decreasing technically, but the speed is the absolute value of that. So my speed is actually going to be a positive 500. And in what units? Well, they told me miles, right? And they told me per hour. So they told me my units right there.